sine x cosine x equals 1/2. Let's multiply both sides by 2. I don't see anything right now that helps me out, but let's get rid of that fraction at least and see what happens. So multiply both sides by a 2. That does help me because 2 sine x cosine x, if I remember that, that was one of my double angle identities, which is a sine of 2x. And set that equal to 1. So again, just if I recognize or if I scan through my list of equations, there was an identity, or my list of identities, there was an identity there that was helpful. So what angles or what sines produce a value of 1? That happens where 2x, or this value will be a pi halves. So what that means again is that I know that the sine of pi halves equals 1. So this value of 2x is where that happens. So what values of x do that at? Since this repeats also on every 2 in pi, I have all those values to consider. I'll rule some out later, but I'm going to consider them. So let's solve this for x. Divide both sides by 2. Yep, divide both sides by 2. Yeah, divide 2, gives me pi over 4 plus n pi. So there's a model that's going to help me determine where all my solutions are at. So let's check the first one. Let's check at n equals 0. Put in 0, it produces pi over 4. That's within the range. That's a good solution. Put in n equals 1. That produces a pi over 4 plus a pi. I can't tell right away, so let's add them together. And so that's pi over 4 plus 4 over 4 pi, and that's 5 over 4 pi. That's within that range. That one checks. Let's try n equals 2. Pi over 4 plus 2 pi equals, and right now I see that I have anything plus a 2 pi, that's too big. So I have two solutions that meet these particular parameters.